Hello class, this is our second video for chemistry. What we're going to be talking about today is what does the periodic table look like and what does the information on the periodic table tell us. But first, let's take a review from last week. In our last video, we talked about how we can use the acronym PEN or PEN to remember the different subatomic, meaning really small, so the subatomic parts of an atom. Remember that P stood for protons, and they had a positive charge. E stands for electrons, and they have a negative charge, while N stands for neutrons, and they have a neutral charge. And I'm going to represent that with a big donut. We also discussed where these are located within an atom. Our protons and neutrons create the center of an atom, also known as our nucleus, while our electrons sit on the outside in our electron shells on the outside of our nucleus. What's important to know is that everything around us is made up of elements, and elements are made up of atoms. And atoms have different parts and look different ways depending on what element they're representing. So a lithium atom is going to look a lot different than a copper atom or an aluminum atom. And what we're going to do today is determine how does looking at the periodic table inform us on how many PENs, protons, electrons, and neutrons, there are in certain atoms and what that structure looks like. What you might also notice is that the periodic table is all different kinds of colors, and that they're shaped in these different columns and rows that look a certain way. And we're going to be talking about those at a later date, discussing why they're organized in a certain way. However, the one thing you should note is that the periodic table is organized from left to right in numerical order. And we're going to talk about why that is in just a second. When we look at the periodic table, we see that there are all of these little squares, and all those squares are called elements. In these elements, there are specific numbers that correspond with this element. So right now, if we zoomed up to the periodic table and we looked at the key, we would see that the sixth one is carbon. Okay, this number at the top represents the atomic number. And the atomic number is where we have our protons and neutrons. These are the sum of those two things. So we know that protons and neutrons are always going to be the same number. So for carbon, I have 6 protons and I have 6 neutrons. What I see under the atomic number is my element symbol. And basically the way that I like to remember it is that we all have initials, like Miss Tackett's is KNT, Kelsey Nicole Tackett. An element, its initial or element symbol in science talk is a C. It's that simple. Now sometimes when you're looking at the periodic table, what you might notice is something like silver might have an element symbol such as Ag. Okay, and there might be differences in those names. So it's not always the first letter of what element it represents, but sometimes they vary in what they are, like sodium is Na. What I want to draw your attention to next is after we have the element symbol, we have the element name. So we know that C is carbon. And what you'll always see at the bottom of your key is that you're going to see a number that is usually always decimaled. Not usually always, it's always decimaled. Okay, and that's going to be your atomic weight. And the atomic weight represents how many protons and electrons are in that atom. So still, what's our most important part to realize is that we still need to pay attention to our PEN, our PEN. So we need to find out how many protons, electrons, and neutrons there are in a carbon element. So when I'm looking at this key, I remembered that my atomic number up here represents both protons and neutrons. So So that means there's 6 protons and 6 neutrons. This number, which I'm going to round to 12, tells me how many protons and electrons I have. But I already know that there are 6 protons, so I'm going to subtract 6 from 12, and I get 6. That's going to tell me that I have 6 electrons in my carbon element. If I remember from the last video, I know that my protons and my neutrons create the nucleus of my atom. And I already told you that there were going to be 6 protons, 6 electrons, and 6 neutrons. So let's make sure that I'm correct. There's 1, 2, 3, 4, 5, 6 protons, 1, 2, 3, 4, 5, 6 neutrons, 1, 2, 3, 4, 5, 6 electrons. So this picture is accurate because it has 6 of each subatomic parts. It has my protons, neutrons, and electrons properly labeled with the correct positive, negative, or neutral symbol. And it also remembered that I can only have 2 electrons in my first electron shell, and then I can have more. What this is it's the correct model of what an atom should look like. And the reason why it's so important to remember our electrons and where they're placed is because later on we have to discover how do these bond to make substances that we know and we use every day. Like H2O, we know is water, which is hydrogen and oxygen bonded together. And we'll learn more about that in the weeks to come as we continue to discover more about chemistry. So again, let's look at this and see how many protons, neutrons, and electrons we should have. So remember, P, E, N. If I look here at my atomic number, I remember that 7 tells me my protons and my neutrons. So half the work is already done. The atomic mass at the bottom, I'm going to round and let that be 14. And I'm going to subtract it because both of these numbers represent protons. The one on the bottom represents protons and electrons, while the one at the top tells me protons and neutrons. So I'm going to subtract. When I take 7 from 14, I still have 7. So I have 7 of each subatomic part in the nitrogen element as well. Knowing that I have 7 protons, 7 electrons, and 7 neutrons, I can go ahead and start building my model of my atom. So I remember that my protons and neutrons make up my nucleus. So I already know that I'm going to have 7 protons, and I'm going to label these with dots. So I have 1, 2, 3, 4, 5, 6, 7. While I also have 7 neutrons. 1, 2, 3, 4, 5, 6, 7. And those can be anywhere mixed up together in no certain order, and that's okay. So I went ahead and got rid of my protons, rid of my neutrons, and all I have left are my electrons, and I have 7 left. And I remember that in my first electron shell I can only have 2. So I'm going to represent those with blue dots, 1, 2, and I still need 5 more. And I remember that my first shell holds 2, while my second shell holds 8. The third shell can hold 18, and the last one can hold 32. So I'm going to go ahead, I have 2, and I still need 5 more. 1, 2, 3, 4, 5. And this would be considered a correct model for a nitrogen element because it includes my protons, neutrons, and electrons. Now, if I were in class and I were making this more zoomed in version, I would definitely go back and make sure that I have all of my parts labeled. So I would have negative signs on each of my electrons, making sure that the person who's looking at this knows that those are negative, and having each of my teeny tiny protons marked so that we know that they're positive. So just to review before you go on and do your activity and your fill-in-the-blank notes, we're going to go ahead and look and remind ourselves that this 3 is called our atomic number. And it represents our protons plus our neutrons. This Li is our atomic symbol. It's kind of like the initials. And this is considered our element's name. While this decimal number at the bottom is going to be our atomic mass. And that's represented by our protons and our electrons. So remember, to find our protons and neutrons, we look at atomic number. To find out our electrons, we have to do that little bit of math where we take atomic number and subtract from our atomic mass. What you should leave knowing today is what is the atomic mass and how do we find it, as well as the atomic number. What is the element name and symbol, and where do we find it when we're looking at a key on the periodic table? And how do we determine our protons, electrons, and neutrons just by looking at a simple key like we did for carbon and nitrogen? Make sure that if you're confused about anything that you go and rewatch this video. Make sure that you fill in the blank notes, and any questions you might have, please bring them to class and we'll go over them during your catalyst. See you tomorrow.